to consider samples of phosphine, water, hydrogen sulfide, and hydrogen fluoride, each with a mass of 119 grams. Rank the compounds from the least to the greatest number of hydrogen atoms contained in the samples. Okay, so we just need to find out basically the mass percentage of hydrogen in all of these different samples. So this is a multi-step question. So first we want to find the molar masses of each of these compounds. Okay, so step one is to find the molar masses. So this is just done by looking at your periodic table and finding out the atomic masses of each of the atoms involved in the compound, and then just multiplying them if we need to by how many atoms there are of each in the compound. So for example, the molar mass of fluorine would just be equal to the molar mass of phosphorus plus 3 times the molar mass of hydrogen. So the molar mass of phosphorus is 30.974 grams per mole, and the molar mass of hydrogen is 1.01 grams per mole. So the total molar mass of phosphine ends up being 34.0 grams per mole. Okay, so next let's do the molar mass of water. This is just 2 times the molar mass of hydrogen plus the molar mass of oxygen. So again, the molar mass of hydrogen is 1.01, and the molar mass of oxygen is 15.99. So its molar mass around 18.01 grams per mole. So next we have hydrogen sulfide. So its molar mass is just 2 times the molar mass of hydrogen, which is 1.01, plus the molar mass of sulfur, which is 32.06. Okay, so this gives us a molar mass of 34.08 grams per mole. And then lastly, we have hydrogen fluoride. So its molar mass is just 1.01 plus 18.99. This is just around like 20 grams per mole. Okay, so now that we have all of the molar masses, the second step is to find all the number of moles when each of their masses is 119 grams. Okay, so starting with phosphine, to find number of moles, it's just going to be mass over molar mass. So we know that our mass is 119 grams, and our molar mass of phosphine is 34.0 0.0 from the previous step. So this gives us the number of moles, which is 3.5. Okay, so now let's do the same thing for water. It is 119 grams divided by 18.01 grams per mole, which is equal to 6.6 moles for water. Number of moles of hydrogen sulfide is the 119 grams divided by 34.08. Okay, so its number of moles is 3.5. And then lastly, for an HF, it is 119 grams divided by 20. Okay, so this is 5.95 moles. Okay, so now that we have all of the number of moles, we want to find out the greatest number of hydrogen atoms contained in the sample. So for part 3, maybe I'll do this on another page just so that we have more room. Step 3 is just to multiply by Avogadro's number. And also how many atoms of hydrogen there are in each compound. Okay, so starting with phosphine, we found its number of moles to be 3.5 from the previous step. We need to multiply by Avogadro's number, which is 6.022 times 10 to the 23 molecules per mole. And as for the number of hydrogen atoms, there are 3 H atoms in one molecule. So these units will cancel out, our moles will cancel out. And for phosphine, we get 6.33 times 10 to the 24 hydrogen atoms. Okay, so next let's look at the water. Its number of moles was 6.6. Multiply it by 6.022 times 10 to the 23. And in water, there are 2 hydrogen atoms. So then this gives us 7.95 times 10 to the 24. Next, we have hydrogen sulfide. So its number of moles was also 3.5. And it had 2 hydrogen atoms in 1 molecule of hydrogen sulfide. So then this gives us 4.22 times 10 to the 24. And then finally, let's look at hydrogen fluoride. So its number of moles was, I think, 5.95. Yeah. Okay, so we're multiplying by Avogadro's number, molecules per mole. And in hydrogen fluoride, there's only 1 hydrogen in 1 molecule. Okay, so this gives us number of atoms to be 3.58 times 10 to the 24. Okay, so lastly, we need to rank from least to greatest number of hydrogen atoms. Okay, so now let's just look at all of our values. The lowest number is hydrogen fluoride. And then next is hydrogen sulfide. And then phosphine. And then water has the greatest number of hydrogen atoms in the sample. Okay, so now let's just see what the junior tutor said. Get the number of hydrogen atoms in each compound. We use the Avogadro's number and the subscript of each atom. Also use the molar masses of each compound using the atomic masses of each constituent element. Okay, so first they just wrote down all of the atomic masses of phosphorus, 30.97, hydrogen 1, oxygen 15.99, sulfur 32.06, and fluorine 18.99. We express the number of atoms in terms of Avogadro's number Na. So notice that they don't actually multiply by the 6.022 times 10 to the 23. So this might make it easier, just so that we have, just so that we're working with just easier numbers. Since all of them are multiplied by Avogadro's number, we just need to see the largest after you multiply by however many hydrogen atoms. So here you can just see they fit it all in one line. So starting with 119 grams of phosphine, they divided by its molar mass, which was the 30.97 plus 3. And then they showed how you would convert to molecules. And then they showed how the molecules will cancel out if you multiplied by atoms. Okay, so they got 10.5. So if we were to multiply this 10.508 by the 6.02 times 10 to the 23, then you would get the 6.33 times 10 to the 24. But this is still correct. Let's see what they did for water. The same thing. 13.22. Hydrogen sulfide, 119 times 1 over 32 plus 2. And then they multiplied this by 3. And I think it should have been 2. But it could have just been a typo. Let me just double check. This would be equal to. Yeah, so they meant to write 2 hydrogen atoms, but they still got the 6.987. And then lastly, hydrogen fluoride, 119 divided by 18.998 times 1. Yep, so this solution is correct. I'll just take note of typo for hydrogen.